Continuing on with our circles, we're going to look at some more angles. We've already looked at angles where the vertex was in the center of the circle. We already looked at angles where the vertex was on the edge of a circle. Today we're going to look at what happens when the vertex is just anywhere inside the circle and then also outside. So I've got a little chart to help us keep everything organized. And again, we want to make sure we can identify the vertex and then use it to find angles and arc measures. So angles and the arcs that intercept them have different relationships depending on where the vertex is. So it's all about identifying where it's at. These are like little tiny formulas almost. So the first one we already talked about is when you have the vertex in the center of the circle. So that would be something like this. Oh, excuse me. I'm sure you guys love that. So if this was, say, 30 degrees, you guys would know that that's 30 degrees where it intercepts that arc there. So the angle is actually equal to the intercepted arc. Okay, that one's pretty easy. Actually, these all are pretty easy. That's about as easy as it can get. The second one is where it's on the circle, or we call that an inscribed angle. And that would be something like this. Vertex is down here, opens up, and if this was, say, 30 degrees, this is 60 degrees where it intercepts that arc. So the angle, again, we're talking about the angle where the vertex is at, is actually equal to half the arc. If the arc's 60 degrees, then that inscribed angle is 30 degrees. The two new ones that we haven't talked about yet, one is when we have a vertex anywhere in the circle. So for example, something like this. I should start that over. Let's get this a little bit neater. Okay, and we maybe want to find this angle. Okay, so your two intercepted arcs are right here and right here. The way you're going to find that angle is by taking the averages of the arcs. So you would take, we can call them, I guess it doesn't really matter, arc 1 plus arc 2 all over 2. Okay, because you're taking the average. So for example, if this was 40 degrees and this was 20 degrees, you would do 40 plus 20 and you would get, this is 30, and vertical angles means that's 30. Okay, so you're taking the average. Last one, when you have it outside the circle, so something like this, and we want to find this angle, and again, here are two arcs that it's intercepting. We're going to take arc 1 minus arc 2 all over 2. Now you do want to be careful here because you want to always take the biggest arc minus the smallest arc, because if you go the other way around, you're going to end up with a negative answer. So for example, let's say this was 60 degrees and this was 20 degrees. You would do 60 minus 20 is 40, divided by 2 is 20 degrees there. Okay, so that's really all we're focused on today, is these four, using them and sometimes using them together. So we're going to look at a ton of examples, and I'm going to go pretty quickly through them, so if you need to, go ahead and rewind. Let me pause this so I can shut my dogs up. Hold on. Alright, anyways, sorry if they're jumping around in the background. They're dogs. What are you going to do? Alright, so in these, all we want to do, first state the vertex, so find the vertex in every single one of them, and then decide which one we're going to use. So always refer back to here if you need to. This will be a good thing to refer back to. And what it says is, anytime it's inside the circle, to find out our... Uh-oh. Sorry about that. I thought we were going to have a little freak out here. To find out our average, or to find out our angle there, it's really the average of these two intercepted arcs. So what we're going to do to find out x, we're going to take arc 1 plus arc 2 all over 2. And I'm just going to punch that all in at one time. 132 plus 44, I believe that's going to give you 176. Yes, it does. Divide by 2. So that angle would be 88 degrees. And it's as simple as that. Just following those little basic formulas. Here's another one. You have an angle right here, or a vertex right there of 115 degrees. It's intercepting this entire arc there. Again, go back and look. Up here it says if that's where it's sitting on the circle, then it's double this, or 230 degrees. If that's 230 degrees, we know there's 360 degrees in a circle. So to get x, we're going to take 360 minus 230, and you get 130 degrees. Good. Okay. Next one. A little bit different. Again, we're trying to figure out where the vertex is. It's right there. Here's my two intercepted arcs. So the x equals 129 minus 56 all over 2. So x is going to be equal to, what is that, 73 all over 2, I believe. 129 minus 56 divided by 2. We'll call it 36.5 degrees. Again, it's as simple as that, looking back at your formulas and then going ahead and plugging them in. Number 4, those arcs, or I'm sorry, those chords are congruent, which tells us these two arcs are congruent. So if that's 128 degrees on that side, so is this. So these are both the same from there to there. So those are the same. So far we have 256 degrees of the circle. Okay, kind of working backwards now here. We have 128 plus 128 is 256. So left over right now we have 104 degrees. Okay? So that means from here to here is 104 degrees. That would give us a total of 360. Now if that's 104, x is going to be equal to 1/2 of that, or 104 divided by 2, which is 52 degrees. Okay, because that inscribed angle is half. Number 5. Now we're going to start playing with the formula a little bit. Your vertex is right here, and you actually know your angle this time, and you want to try and find your arc measure. Still going to set it up the same, so we know that x is equal to arc 1 plus arc 2 all over 2, except for this time we actually know x. I guess I shouldn't use x. Let's call it angle. I know my angle is 93. Here's one of my arcs. Here's my other arc. So I'm going to say arc 1 plus arc 2 all over 2. A couple different ways you can do this. You can put it over 1, cross multiply, or you could have multiplied both sides by 2 and gone from there. Doesn't really matter. I guess I have it set up like this, so I'll go ahead and keep going with that. 186 equals x plus 109. So x is going to be 77 degrees. And again, you could quickly check that. Just do 77 plus 109 divided by 2, and you get back to 93. Okay. Another one. Vertex is out here. Here's one arc from there to there, and actually butts up right with the second arc from there to there, so you gotta be careful. So our angle is equal to arc 1 plus arc 2 all over 2. We know our angle is 88. We know, I'm sorry, whoops, we do not want to add that. We want to subtract that. Minus arc 2, so we have 88 equals 225 minus x all over 2. Again, same kind of idea. This time, instead of cross multiplying, I'll multiply both sides by 2 so you guys can see it doesn't really matter. So you get 176 equals 225 minus x. Subtract 225 from both sides. And yes, you're going to get a negative, but that's okay, because in our next step, you're going to see you have a negative x, so that just becomes a positive 49 degrees for your arc. So again, you could double check it, 225 minus 49 all over 2, and you'd get back to 88 degrees. A few more. Number 7. Again, identify the vertex. And its arc, its intercepting, is actually right here. Okay. So the way we want to handle this one, we're given 132 degrees of the circle so far. So again, we know that 360 minus 132 equals 360 minus 132 is going to give you 228. Yep. So this is 228 degrees. Again, if you need to refer back, look up here, that inscribed angle is half. So x is going to be equal to 228 divided by 2. So sometimes they get a little tricky just with where things are at, but the formulas, if you want to call them that, stay the same. Okay. If you feel like you can work ahead and kind of rewind and check your answers, that's fine. Again, they're pretty much all very similar to this using those formulas. Number 8, vertex is right here, intercepts this arc, intercepts this arc, and then just for color differences, I'm going to go ahead and intercept this arc. So those are the two it intercepts. And again, we have an unknown angle, we have one arc we know, and we actually know the other arc by doing 360 minus 110. So that's 250 degrees. So again, this is one that you might want to write down. I find this easier to write down. So your angle, or your x, I guess, let's call it angle for now, equals arc 1 minus arc 2 all over 2. So that x is going to be equal to 250 minus 110 all over 2. So that's going to give you what? 140 divided by 2, or 70 degrees. Again, not overly complicated. Number 9. That's a central angle. That's the easiest one we've got. 122 degrees from here to here. So to figure out x, or the rest of that, we're going to do 360, or x equals 360 minus 122, or x equals, what is that going to be, 238 degrees. Okay. And the last couple here, 10 and 11. So a shorter video today. Vertex is right out here. Here's one intercepted arc. Here's another intercepted arc. Okay. And now this one, a little bit trickier. Again, we want to do angle equals arc 1 minus arc 2 all over 2. We've done stuff like this with segments before, and now we're going to just do it with curves. If we know that red arc is x, and we know there's a total of 360 degrees in the whole circle, then we would label this outside circle as 360 minus x. Because if that was 100 degrees, you guys would do 360 minus 100. If it was 150, you'd do 360 minus 150. So you guys get that idea. So we get 84 equals 360 minus x all over 2. Because we have the 360 minus x, maybe I'll keep it in parentheses so you can see exactly where that's coming from. And again, nothing changes here. I'll do this one by cross multiplying, just changing it up. 168 equals 360 minus 2x, because you have a negative x and another negative x, that's negative 2x. Subtract 360 from both sides, and again, that's okay that we're getting a negative number here, because we're going to get rid of it in a second. So we get negative 192 equals negative 2x, so x is equal to 96 degrees. Again, you can self-check these answers very quickly just by plugging back in. See what happens if you have this is 96, and then 360 minus 96 would be what? 264 degrees. So you could check that really quickly by doing 264 minus 96 divided by 2, and you'd get back to 184. And the last one, number 11. We want to find x, y, and z. Well, we know that this right here is right on that angle. We have another one right here. We have another one right here. So we have actually 3 vertices. So we're going to use them at different times. First one that's easy to see is that this angle, or this arc right here, is across from that inscribed angle. If that inscribed angle is 40 degrees, this angle would be 80 degrees, or double it. Okay? We see that that angle over, or that diameter there, is cutting the circle in half, just like any other diameter there. So we know from here to here, that's going to be 180 degrees. Several ways you can figure out the last part. You can do 360 minus the 2 we already have. You could do 180 minus 80. It doesn't really matter. No matter what we do, we're going to find out that this this arc measure from here to here is going to be 100 degrees. Which means if that's 100 degrees, then z is half that, or 50 degrees. So x is 180 degrees, y is 80 degrees, and z is 50 degrees. So again, not overly difficult. You might have to play around with some before you really see something happening, but you have inscribed angles where it's on the circle. You have central angles, which are the easy ones, and then inside and outside circle, which are very similar. One you add, one you subtract. That's all I got for you guys.
Everything is awesome.
See ya.